All right, guys, we're going to go ahead and start the test review for Chapter 7. Make sure to watch the whole video very closely. There might be some bonus scattered throughout the video, so watch the whole thing. Now, start with number 1. It says, changing a subscript in a correctly written chemical formula will C. Change the formula so that it no longer represents the same compound. Number 2, it says using the stock system of nomenclature. This is the system that we learned. Cr2SO43 is named. Well, first we look at this and we see that we have chromium, and we know that that's a metal, so it's an ionic compound. So we go ahead and we see that chromium is in D block, so it needs to do the right triangle rule. The oxidation number of sulfate is -2, so it matches the subscript of 2. So that means that the 3 subscript over here, remember, right triangle, the 3 is our Roman numeral, so this is going to be D, chromium 3 sulfate. The next one, it says, in a polyatomic ion, the algebraic sum of the oxidation numbers of all atoms is equal to, and it should be D, the charge of the ion. Number 4, it says the sum of the atomic masses of all the atoms in the formula for a compound would most properly be called, and the answer would be B, the formula mass. Number 5, it says the empirical formula may not represent the actual composition of an, and the answer would be D, molecular compound. Okay, moving on to number 6, it says the formula for phosphoric acid is, when we're looking at phosphoric acid, what we need to realize is that since it doesn't have the prefix hydro, we know it's an acid, so we look and see that since it doesn't have hydro, it's not a binary acid. So we see that IC ending, that means a polyatomic is involved. We have hydrogen bonded to a polyatomic, and in this case it's going to be phosphate, which is PO4. Now we see that hydrogen always has a +1 oxidation number. Phosphate has a -3 oxidation number. We crisscross those guys, and we have HPO4, or H3PO4, which is D. Number 7, it says the term formula mass can be applied to both ionic compounds and molecular compounds because, and the answer would be C, not our formulas represent individual molecules. And moving on to number 8, so to determine the correct molecular formula for an empirical formula, one must determine the blank of the compound, and the answer would be B, formula mass of the compound. Alright guys, we're going to skip 9 through 12. You really don't need to worry about the oxidation numbers. We're not going to be tested over that. So moving on to 13, and it asks us to write the formula for the following compounds in the space provided. Now, so we're going to write the formulas starting with 13. We have silicon dioxide. Now we have to determine what it is, and we know it's not an acid because it doesn't tell us. We know that it's not an ionic compound because it's not a metal. So we see that this is going to be a covalent compound, and we just write down exactly what we see. So we have silicon, which is Si, and dioxide. So what that means is dioxide is going to be O2. And next we move on to 14. We have carbon tetraiodide. So that basically means we have another covalent compound, because anytime you see a prefix of the Greek prefix system, you know, any of the monodi, tris, tetra, penta, hexa, hepta, octa, nona, deca, that you got a covalent compound. So we write down what it tells us. We have carbon, which is just by itself, and then tetra is 4, and iodide is iodine, so Ci4. Okay, moving on to 10 for chromate. Here we see that we know it's not an acid, doesn't tell us. We know it's going to be an ionic compound because we see a metal. And 10 is going to be Sn, and chromate is going to be CrO4. Now we have to crisscross these guys, and we crisscross everything except our covalent compounds on top. So 10 is going to be +4, and we get that from that number right there, 10,4. And then chromate is going to be -2. When we crisscross those guys, and we see we get SN2, and then CrO4 with a 4 on the outside. And since it's on the outside of the parentheses, we can reduce this. So our final formula is going to be SN parentheses CrO4 parentheses and a 2. And finishing off with barium hydroxide, we see that we have barium. It's an ionic compound because there's a metal. So barium is going to be just Ba. And then hydroxide is a polyatomic, it's OH. And what we're going to do is crisscross the oxidation numbers. We see that barium is going to have a +2 oxidation number, hydroxide is -1. Crisscross those guys and we get Ba1OH2. Okay, which would just be written without that 1, just BaOH2. Okay, moving on to 18, and we see that 18 is going to be a covalent compound, so we use the prefix system. So we see that we have a 2 and we have a 4, so we're going to have dinitrogen, and this is going to be tetraoxide. So dinitrogen tetraoxide. Moving on to 19, we see that we have iron, and then we have NO2, which is nitrite. Now, iron is a D-block metal, so we have to give it a Roman numeral. So what we see is we're going to do the right triangle rule. We know that the oxidation number for nitrite is -1. We see that it matches the subscript of iron, which is 1. So that means the number on the outside of the parentheses, that's our Roman numeral. So it's going to be iron 2 nitrite. Moving on to 20, we see that we have a covalent compound, so we're using our prefixes. We have carbon, 4 being tetra, so we're going to have carbon tetrachloride. 21, again we have a covalent compound, and we see that we have carbon by itself, and then we have oxygen by itself, so it's going to be carbon monoxide, so carbon monoxide. And then lastly, we see we have copper and we have carbonate. And we know that copper is a D-block metal, so we have to use the Greek prefix system. And we're going to go ahead and put parentheses around this polyatomic. And we're not using the Greek prefix system, we're using Roman numerals. So we just look and we see that, hey, carbonate has a -2 oxidation number. The subscript does not match the oxidation number. Remember, we're just looking at the numbers, not the signs. So what we do is we know that there's parentheses around carbonate, and that 1's on the outside of the parentheses. So all we do is we multiply that 1 by that 2, and we get 2. So this is going to be copper 2 carbonate. Guys, this is a good place to mention that polyatomic ions are very, very important for this test. We need to know those. Very, very important. All right, guys, moving on. We see that we have 23 through 26, and we're going to go ahead and write the formulas for them and give the names. And we see that all of the compounds here, we have metals, and then we have non-metals, so all these guys are ionic. So basically, we're just practicing our crisscrossing, and then we're going to name it. So basically, we start here, and we have calcium, and we have chlorine, and we crisscross those guys. So the formula is going to be CaCl2. And it would just be named calcium chloride. Here we have lead with the +2 oxidation number. We have chromate with a -2 oxidation number. We crisscross those guys, and we see that we'll get Pb2, and then in parentheses CrO4 with a 2. And since they're on the outside, we can reduce those guys. So the final formula we're going to end up with is PbCrO4, which this would turn into lead-2 chromate, because we're going to give the Roman numeral, which we get from the oxidation number to lead. In 25, we crisscross these guys, and we see that we're going to get Al2, and then parentheses SO4 3. We see we have aluminum and sulfate, so we would just name it that, aluminum sulfate. And then lastly, we see we have 10 with its oxidation number, and then we have phosphate. We crisscross those guys, and we get SN3 3, and then parentheses PO4, and then 4 on the outside. And we would name this 10,4 phosphate. All right, guys, we're going to go ahead and skip all the way down to 36. Don't worry about the ones we skipped, but we're going to start here. And it says, what is the molar mass of tetraethyl lead? And what we see here is it gives us the formula over here, and it wants the molar mass. And remember, the molar mass is basically the same as the formula mass, except we just changed the unit to grams per moles. So we're going to find it the same way we find our formula mass. So we set it up, and we see we're dealing with lead, we're dealing with carbon, and hydrogen. Okay, and then we look in our formula and we figure out, well, how many of each one of them are we dealing with? Lead only has a subscript of 1, so we're dealing with 1 lead. Carbon, we see that it's in parentheses and it has a 4 on the outside of the parentheses. So we distribute that 4 to both carbon and hydrogen. So carbon is going to have 8 and hydrogen is going to have 20. Now, what we're going to go ahead and do, because we're getting the formula mass, it's the mass of a formula, we're going to multiply those guys by their atomic masses on the periodic table, which lead is 207.2, carbon is 12.01, and hydrogen is 1.01. And we multiply those guys out, and we get numbers of 207.2, and we get 96.08, and we get 20.20. Okay, and we add those guys up to get our molar mass. So when we add it up, we'll get a total of 323.5, and that would be grams per mole. And it actually would be 323.48, but we went ahead and rounded it. And guys, remember on your test it's going to be multiple choice, so you don't have to worry about rounding too much.